Hello everybody, this is Alberto Montes. I'm making a short video for Fundamentals of Physics, term 1505. This month our instructor was Miss Rombach. So today I'm going to talk about oscillation and dampening and how they apply to my degree of mobile development. It took me a minute to figure out something that really applies well to mobile development and from the physics field without it being mobile gaming. I was going to do mobile gaming, but that's not the core of my degree, so I decided to show you how it relates in terms of mobile animations. So first, I want to define the two terms I want to talk about, and then I will give you examples on how they apply to my little app here and the animations. First, we have oscillation, which is just a regular variation in magnitude or position around a central point. So to think about it in an easier way, think of an object with mass hanging from a spring that's suspended and then pulling on that object, and as it goes up and down, it's changing position around its central point of equilibrium. So basically it's just bouncing up and down. And then damping is just basically the process of decreasing the amplitude of an oscillation, or just effectively restricting its oscillations. And I'm going to show you how we use that and how we damp in mobile development. So here's a simple application. I wanted to make it, has 3 buttons and some instructions, but I wanted to make it look a little cool when it started, so we add animations to the buttons and the instructions. And here you can see is where the animations take place. And right here, the very interesting part, using spring with damping. And it's funny because I just saw this and had no idea what it meant. I was just playing with the numbers this probably 2 months ago. And then we learned about it in physics, and it just made things a lot clearer for me. But as you can see here too, also we have an initial spring velocity. I'm not going to go much into that today, though. We're just going to talk about the spring with damping, but you should be very familiar with velocity now, and we're just going to start with a low number of 1, so things aren't going to move too fast. So anyway, this is what we would call being underdamped. It's damped so that it does change the oscillations, but it's not too, it's not on either high end of the spectrum. It's not 0, it's not 1,000, it's just underdamped. We're just adding a little bit of damping, and you can see the effect that it has on our on-screen objects here. You see how they oscillated a bit up and down, and then it took for a minute, then they came down to their equilibrium, which is a predefined point on the screen. Now I'll show you what it would look like with 0 damping. So our spring has 0 damping. We didn't add any kind of resistance in there, and you'll see how crazy it looks and what damping actually does. All right, do you see all that oscillation? It was like some crazy oscillation. It was hard to even follow with your eyes. It was going up and down so fast. But you'll see what just changing that 0 to 0.5 does. Now we want to totally add a ton of restriction here. Let's go to 1,000. This would what we would call critically damped. It's super damped, but it's not damped to like the point where it doesn't oscillate at all. But you'll see the difference. Boom, it just goes right to equilibrium, oscillates that one time, and I think that pretty much effectively shows how oscillation and damping relates to my mobile development field. Thanks everybody for watching. I had a great month. I learned that physics is life. Physics is all around us at all times, and this course has definitely brought a greater understanding to many things around me and many things in my field. And I hope everyone benefited as well. Thanks for watching, guys. Good luck in your next classes. All right, bye-bye.